Hello guys, welcome to Let's Learn. Today I am here with the topic of the time value of money concept. The time value of money. Let's turn to the meaning of time value of money. Effect in the value of money due to the time is known as time value of money concept. The value of money which will be lesser than today in some future days is known as time value of money. Time value of money is the idea that the money available at the present time is more than that is available in some future days. There are mainly two techniques of time value of money. These are the compounding techniques and the discounting techniques. Let's turn to the figure to understand the compounding and discounting techniques. When present value is converted to future value, then it is said to be compounding techniques, and future value is converted into present value, then it's said to be discounting techniques. Let's turn to the compounding techniques. These are of when the present value of any amount converted into the future value, then it is said to be compounding techniques. Compounding techniques has the total four cases. These are the future value of single cash flow, future value of equal even cash flow, that is known as annuity, future value of unequal cash flow, and future value of annuity due. Let's turn to future value of single cash flow. Suppose when only one installment is receivable, that is the principal plus interest, then it may be said to be a future value of single cash flow. For example, Mr. A deposited 1 million in fixed deposit accounts at ABC Bank at the rate of 10% per annum. What is the total amount at the end of fifth year? We can find the total amount with these two ways. Let's turn to the solutions. We have two ways: formula method using PV times 1 plus I to the power n. We have the present value is 1 million, n is 5 year, I is 10%, that is 0.10 times. Put each value in the formula and we get the 16 lakh 10,510. Now we can see that bank will provide to Mr. A 16,10,510 dollar at the end of fifth year. Let's turn to the table method. Using PV times FVIF in nth year at I%, we have see the FVIF table in fifth year at 10%. The factor will be 1.6105. Now multiply it by the present value and we get 16,10,500 dollar. Now we can say that bank will provide to Mr. A 16,10,500 at the end of fifth year. Sometimes answer may vary with these two methods, but don't worry, it comes only due to the rounding of a factor. Here answer vary by $10, which is only due to the rounding of the factor while calculating the factor. Now looking for the FVIF table. Here marked portion is this 10% in fifth year, which is known as the interest rate of future value is in fifth year at 10% is 1.6105. Now turn to the another case of compounding techniques. That is the future value of multiple equal cash flow, that is also known as the annuity. When equal installments are payable or receivable in the equal time interval for a specified period, then it can be called as annuity. For example, Mr. A has to deposit the amount of $200 each month for 3 years to discharge the loan. This type of installment is called the annuity. Now turn to the calculation. It can be calculated by the use of the PVIF table. Future value equals to A times FVIF A in nth year at I%, where A equals to annuity and FVIF A equals to future value of interest factor of annuity. Now let's turn to the calculations. sorry, example. Mr. A deposited amount of $1,000 each year for 5 years in XYZ Bank at the rate of 10% per annum. What will be the total amount in his account? Let's turn to the solution. Future value equals to annuity times FBI of A in nth year at I%. Now, the annuity is 1000 and the factor is 6.1051 and we get $6,105.1. Now we can say Mr. A's account shows at the end of 5th year is $6,105.1. Let's turn to the future value of unequal cash flow. Suppose Mr. A invested in a project of 4 million and will get back return $40,000 in first year, $1 lakh in second year, and $1 million in third year, and something like that. This type of cash flow is known as the multiple unequal cash flow. Now let's turn to the example. Example, Mr. Dheeraj deposited in SBI Bank RS 10,000 in year first, 15,000 in year second, 20,000 in third year, 25,000 in fourth year, and 30,000 in 5 year at the rate of 10%. What is the total amount in his account at the end of year 5? Let's draw a timeline. Deposits are like that, and the time is 0 year, 1 year, 2 year, and that. The amount 10,000 is compounded 4 times, 15,000 is compounded 3 times, 20,000 is compounded 2 times, and 30,000 is compounded 1 times. Let's turn to the solution for these questions. Let's draw a table. Here table shows year, cash flow, FVIF at 10% in different year, and future value. Here the amount in year 1 is 10,000, year 2 is 15,000, year 3 is 20,000, and year 4 is 25,000, and year 5th is 30,000. Here factors come from 4th year because this 10,000 amount is compounded 4 times, 15,000 is compounded 3,000 3 times, 20,000 is compounded 2 times, 25,000 is compounded 1 times, and 30,000 compounded 0 times. So it is multiplied by 1 and we get the total future value equals to 1,16,356. Now let's some discussions. All the discounted type of discussed type of cash flows are of regular type of annuity in which all the interest are payable or installment are deposited at the end of year, but sometimes interest are paid at the beginning of period, which is known as annuity due. Let's compare the annuity and annuity due. Here annuity deposited at the end of year and all the amount are deposited at the end of year. Here annuity due deposited at the beginning of year. All the amount are deposited at the beginning of year. Each installment deposited at the beginning of year. Let's turn to calculation. For calculating the future value of annuity due, calculate the future value just as annuity and then multiply it by 1 plus I. Let's turn to example. Mr. Atul deposited $1,000 each year at the beginning of the year for the 5 year at 10% in NMB Bank. What is the total amount at the end of 5th year? Let's turn to the calculation. FB equals to annuity times future value of interest factor of annuity in nth year at I% times 1 plus I, and we get this amount 6,715.10. The total amount at the end of 5th year is $6,715.61. Now turn to the time for Discounting techniques. Where we convert the future value into the present value, it can be called as discounting techniques. In discounting techniques, there are also four cases. The present value of single cash flow. Suppose Mr. BP needs 1,10,000 after 1 year for buying a computer, and for this, how much he has to deposit it right now for this. The amount deposited by the BP right now is present value. And let's turn to the calculation. How to calculate the present value of this type of future cash flow. Calculation. There are two methods. Formula method, future present value equals to future value upon 1 plus I to the power n, where PV equals to present value, FV equals to future value, I equals to interest, and n equals to number of years. Here present value equals to 1,10,000 upon 1 plus 0.1 to the power 1. Here Mr. Bipin needs to deposit this amount. Let's turn to table method. PV equals to PFV times a PVIF in nth year at I%. Now PV equals to 1,10,000 into PVIFA at 10% in 1 year. Now we get 1 lakh. The factor 0.9091 is come from the table. Now see the table. Here we have to choose the rate at 10% in first year. Let's turn to the present value of annuity. Mr. Mukesh is planning for a BBA which requires each year $500 for 4 years. His uncle agreed to pay, but his uncle paid total sum at once. For that, how much his uncle have to deposit his bank account, which provide 10% interest per annum. Now, turns to calculations. Look for factor in PVIF table in fourth year at 10%. Factor is 3.1699. Now multiplied by the annuity which Mukesh is required, and we get $1,584.95. Now we can say Mr. Mukesh uncle has to deposit $1,584.95 at present. Now present value of annuity due. Suppose Mr. Jax needs 10,000 each year at the in the beginning of this 5 year. How much he should deposit for that beginning? Let's consult the timeline. Here is 0, 1, 2, 3, 4, and 5. Annuity is 10,000, 10,000, 10,000, and 10,000. The annuities of 0 year received the 0 year interest, 1 year received 1 year received interest, and like that. And the amount in year 4 received the interest of 4 year. Let's turn to the calculations. Table method. PV equals to A plus A times PVI of A I comma n minus 1th year, where A equals to annuity. And the formula method. We can find the present value of formula method by formula method with this formula and add all the annuities and divide by 1 plus I to the power 1, 2, 3 and n. Here annuity equals to 10,000, equals to 10%, n equals to 5 year. Now PV equals to A plus A times PVI of A n minus 1th year at I%, and we get 41,699. Now we can say that Mr. X have to deposit 41,699 for fulfill his needs. Present value of unequal cash flow. Suppose you are looking for an investment which provides the return of 10 million in year 1, 12 million in year 2, 14 million in 3, 16 million in 4, and 18 million in year 5, and the rate of interest is 10%. An initial value of this investment is 50 million. Should you buy or not? For this, we have to calculate the present value of these cash flows. Now, calculation of present value using table method, year, cash flow, present value factor, and present value. The different cash flow at different year are given, and we calculate the present value as 51.6301 million. Here total present value of investment is more than the initial investment. So if you buy this investment, you will be in profit. Thank you for watching this video, guys. Thank you.